Good morning, one and all. Today we are going to start a new session called Power System Analysis. Myself, Dinesh, Assistant Professor, Electrical and Electronics Engineering, Panimalar Institute of Technology, Chennai. Actually, it is a 3-credit paper, 60% of problem and 40% of theory. So, this power system analysis is one of the fundamental course for your electrical engineer. This course will help you a lot when you going to your higher studies or when you going to your job curriculum. It is most essential for your academic curriculum. So we discuss the course in detail for each and every aspect. So first we are going to discuss about what are the objectives involved in this paper. So the first objective is we have to model our power system under steady state operating condition. So that is the main motive of the paper. In the steady state, how we able to maintain our power system, it is the first objective. And in the second objective, we have to apply the numerical methods to solve the power flow problem. It is also essential for your power system analysis. And the third objective, you have to model and analyze the system under faulted condition. We have a lot of faulted conditions in our power system. Generally, we have line to line or line to ground or double line to ground we have. So we have to model and analyze the system under faulted condition. It is quite useful when you are analyzing the typical power system. And the fourth objective is you have to model and analyze the transient behavior of the power system. It is also very essential for your power system. Even though the transient period is very small in your power system, the impact to create because of the transient will create lot of disturbances in our power system. So we have to evaluate your transient behavior also in this lesson. It is quite useful for your analyzing purposes. We move on to the next slide. First one, we have an introduction part. So in the introduction part, we need to plan our system and operational studies and what are the basic components of power system, and introduction to restructuring, single line diagram, per phase and per unit analysis, generator, transformer, transmission line, and load representation for different power system studies, and primitive network, construction of Y bus using inspection and singular transformation methods, and Z bus. So in the first unit, we need to discuss about what is the planning and operational required for your power system, and what is the basic components are required to construct your power system, and what is the essential criteria to require your power system to reconstruct in the faulted state to actual state. It is also very important. And we have to represent our entire power system into single line diagram. So whatever we have the quantities, that is generator, motor, transmission line, or your bus bars, whatever it may be, we have to express in the format of single line diagram, and we have to express the single line diagram into per phase and per unit analysis. So we have to obtain the modeling for your generator, transformer, transmission line, and you have to represent your loads also, because in most of our domestic loads or industrial loads are inductive in nature. So when we study the behavior of your power system, the load representation is also useful. So we have to evaluate the load representation. And what is the primitive network, what is meant by primitive network, we have going to discuss in detail. And how we construct the Y bus. Y bus is nothing but your admittance bus. There are two kinds of Y bus evaluation is available. One is with the help of inspection. It is involved in your basic circuit theory. With the help of inspection, we may construct our Y bus, or with the help of singular transformation method, it is a sort of algorithm, or we may construct Z bus. Z bus is nothing but impedance bus. So impedance bus algorithm, it is also essential for your per unit analysis. We move on to the next slide. So in the second slide is nothing but unit number 2, power flow analysis. So in the power flow analysis part, we have to study what is the importance of power flow analysis in planning and operation of power system. So when we plan and operate your power system, what is the role of power flow analysis in your electrical transmission and distribution, we have to evaluate in detail. And what is the statement of power flow problem, we have to discuss. And what are the classification of buses. So classification of buses in the sense we have three categories. One is your generator bus, and second one is your load bus, and third one is your slack bus. So generator bus, load bus are depends upon your consumer requirement. We have to fix the details. So slack is nothing but a default bus. We have to specify, a designer have to specify the slack bus also. And what is the development of your power flow model in complex variable form. And next topic is we have to discuss the iterative solution using Gauss seidel method. So it is one of the wonderful algorithm to evaluate your power system. And what is the Q limit, that is your reactive power limitation should be checked in the power system. That is, in the load flow analysis you may check your reactive power flow and power flow model in polar form, and what are the iterative solution using your Newton-Raphson method. It is also a computation algorithm. So these are all the following topics we are going to discuss in the unit number 2. Next one is your unit number 3, fault analysis for balanced fault. So here in the balanced fault conditions, your each and every phase, that is your R phase, Y phase and B phase, are each are in phase with other. So when we operating the power system in phase, what are the importance or what is the role involved in your analyzing the fault under balanced condition. So in the balanced condition, what are the essential requirements needed, we have to discuss in this chapter. So importance of short circuit analysis, and what are the assumptions while you consider your fault, and what are the analysis while we using our Thevenin's theorem and Z-bus building algorithm, fault analysis using Z-bus, and computation of short circuit capacity and post fault voltage and currents. These are all the parameters we are going to determine using this unit. It is also one of the short circuit analysis portion. So it is quite useful for your power system planning, operation, monitoring, everything. So fourth unit, fault analysis for unbalanced case. So in the unbalanced case we have three categories. One is your line to line and double line to ground and line to ground. So these are all the three major faults occur in your unbalanced faulted conditions. So here we have to represent our power system in terms of symmetrical components and the sequence impedances, and we have to create our sequence circuits. We have three types of sequence circuits. One is positive, negative and zero sequence. For each and every machine, suppose we have synchronous machine, transformer and transmission lines, we have to form a sequence network using this unit. And what is the analysis over your single line to ground, line to line and double line to ground faults using Thevenin's theorem and Z-bus matrix. So these are all the following topics we are going to cover in the unit number 4. So in the next slide we have a stability analysis. It is one of the essential for your stability analysis. So stability analysis is quite useful for your power system planning and operation. So in order to maintain your power system in a healthy state, the power system stability will play a vital role. And what are the classification of power system stability we have to discuss, and in terms of your angle and voltage. And in our power system we have a infinite number of buses are available, but in our analysis we may discuss single machine infinite bus system, and with the help of your single machine infinite bus system we have to develop our swing equation. It is full and full we have to create our swing equation with the help of your rotor angle. So with the help of your rotor oscillations we may develop a swing equation, and we have to characterize your equal areas for each and every power system. Stableness should be maintained as a areas. So when we found out the areas of your power system, we have to determine what is the maximum critical clearing angle and what is the maximum critical clearing time offered in your power system. So these are all the conventional ways to check our stability. So here we have computational algorithms also. So we have swing equation by modified Euler method and Runge-Kutta fourth order method. So using these two computational algorithms we may easily solve our stability problems. So these are all the syllabus we are going to cover in the forthcoming sessions. So very firstly we are going to discuss about what are the general power system structure. So this is my basic structure of your power system. uh, so here we have the color keys. Blue color indicates your transmission, and green color indicates your distribution, and black color generates your indicates your generation. So here this is my generator unit. So in the generator unit, the electrical energy, that is from your mechanical prime mover we may obtain our electrical energy. So this electrical energy is fed to your generator step up transformer. So whatever we generated here, it should be stepped up to your transmission and distributed parameters. So after my transformer, that is step up transformer, I am having my transmission line and I am having my supporting towers. So in between my first tower to second tower, I'm having my customers. So suppose I am having my industrial customers, suppose my domestic customers. So I have to provide my power in between my transmission lines. So here the 500, 345, 230 and 138 are 110 kV, 66 kV, 33 kV, 11 kV, 6.6 kV. So these are all the formalities of the transmission line available in our power system. So here after your step upping your transformer, the industrial consumers are directly extracted the power here. So after the extraction of the power is over, it is given to your step down transformer. It is given to your customer. So sub transmission customer, here your 26 kV and here it is 69 kV. So these are all the high terms of load customers, and here we have primary customers. So here primary is 13 kV and 4 kV, and secondary is it is our residential loads. It should be maybe your 3-phase load or single phase loads. So here we have to utilize our loads here. So this is the basic structure of our electric power system. So we have to form for each and every machine or each and every line into a per unit quantities here. So it is one of the major motivation. We have to exactly equate for each and every quantities as a base values or per unit quantities. So in the next slide we are going to discuss about what are the planning and operational studies is required to study our power system. So the power balance equation is much needed here. So your demand power, which is equal to summation of I equal to 1 to n PGI. So your I is nothing but 1 to, it moves up to n number of, because when the human life is extended day by day, it is more and more. So your EB connection is also extended more and more. So your I is incremented day by day. So when we are incrementing our generation, so your demand should be satisfied. So your total demand, which is equal to sum of real power generation. So when it's, that is your demand and generation is satisfied, it is nothing but your power balance equation. This condition is not satisfied at all circumstances. It is your demand is always dominating. So when the generation is incrementing more and more, then only your demand should be satisfied. So it is one of the challenge given to the electrical engineers. When an electrical engineer or power system engineer tolerate the demand, it should be in a healthy power system country. So in the next slide, I have to draw a general structure of your need for planning and operation. So here I am planning process is a dual process. So after my planning, I have to implement the plans. So when the planning process is on, what kind of plant I have to erect, what kind of remedial actions I have to take, so I have to plan here in the terms of charting. So after the charting is done, I have to implement the plan, or this is nothing but your proposed plan is going to implement in our power system. So when you implementing the plan in the power system, you have to monitoring and comparing plans with the results. What happens if we install a power system in that location? What happens if we install, or what are the remedial actions we have to take if we install that plant? So if the no desirable actions or no desirable deviation should be takes place, means we have to move on to the planning again, we have to replan again. So suppose undesirable deviation, so undesirable deviation is happening, means we have to take the corrective action, again we are moving to the planning. So planning is a closed loop process, it is a dual process, we have to continue for each and every term in detail. So based on this system planning and operational studies, we have analyze use our circuit using the three categories. One is with the help of load flow analysis. With the help of load flow analysis, we may compute our system planning and operation, or with the help of short circuit analysis, or with the help of transient analysis, we may easily calculate the faulted level, or your need for system planning and operational studies is done here. We continue in the next session. Thank you.